strange phenomenon in mountains that causes them to be burning for thousands of years. Gas that causes mountains to breathe fire is appearing around the world. Ancient recipe for deep earth version of photosynthesis is more common than previously known, scientists think they're finding. At the top of a mountain in southwest Turkey, the ground spits fire. It's known as the flames of Chimera that have burned for millennia, for thousands of years. Local myth long held that these fires were the breath of a monster, part goat, part snake, part lion. Today we know the fuel for this flaming mountaintop is gas escaping from deep within the earth, but it does not come from the decay of ancient plants, algae, or animal life like fossil fuels. Instead, this gas comes from a chemical reaction inside the rocks, and a series of studies published by a group of international scientists known as the Deep Carbon Observatory is showing that this source of gas is more common on our planet than previously known. Giuseppe Etiopi, member of the group who helped discover the cause of the flames of Chimera in 2014, says, "We have discovered these unusual types of methane in many, many sites. It's not a rare phenomenon," he says. Over the past decade, the observatory's community of scientists has found hundreds of gas deposits in more than 20 countries and several spots at the bottom of the sea that are similar to the flames of Chimera. And they've learned that the recipe for these gas emissions is far more complex than previously thought. We now have a better understanding of the different ways we can make methane on Earth. There's not only the biological regime as we know it, said Benedict Menez, microbiologist at the Institute of Physics du Globe in Paris. A biotic methane, as it's called, does not involve decaying plants, animals, or algae trapped in sedimentary rocks like biotic methane. The chemical reactions that produce these gases involve water and rocks sometimes miles below the Earth's surface. And now that I'm reading this, I want to also comment that there are some geologists and scientists that believe that crude oil is produced not by decaying animals and plants, but by the Earth itself. In other words, where we have had crude oil deposits, they may be replenishing. And it could be that there will not be an end to crude oil because the Earth, as it gives, for example, in this case, birth to methane, it also gives birth to crude oil. Now, for years, Deep Carbon Observatory researchers collected and analyzed gas samples from hundreds of diverse sites using special tools to figure out where the methane came from. They have discovered Earth's basic recipe: take hydrogen from water, mix with inorganic carbon from minerals or gas, add another metal-rich mineral to get the process going, and voila, a biotic methane. The hydrogen often comes from serpentinization when water percolates, usually through rocks from the mantle, but the recipe varies. Different sites may use different minerals or carbon sourced from their environments. Hydrogen may come from friction or radiolysis instead of serpentinization. Temperatures may range from below 121 degrees Celsius, which can still support life, to around 482 degrees Celsius, which cannot. So the fires of Chimera were the result of carbon dioxide-rich limestone or calcium carbonate and hydrogen-rich serpentinized rocks that were doused with rainwater. By contrast, in the ocean, at sites like Lost City Hydrothermal Vent Field, most methane formed under the higher temperatures produced when once buried mantle rock were exposed and serpentinized by circulating seawater. In each case, we see chemosynthesis, a deep earth version of photosynthesis, only its energy comes from a chemical reaction and not the sun. Both processes transform inorganic molecules to organic products life can use, which is the basis for all ecosystems on the planet. In some instances, chemosynthesis also produces amino acids, the building blocks of life. With the new tools designed to study Earth's subsurface, researchers can determine whether methane came from ancient life or lifeless rocks, and in doing so, they also reveal secrets about how life may have emerged on this planet and the possibility for life elsewhere, like inside Mars or on the ocean floor of Saturn's icy moon Enceladus. Scientists like Menez think chemosynthesis may have come before photosynthesis and allowed for the emergence of microbes that eat and produce methane. He said, "We know that life did not emerge from scratch," she said, and finding parallels in the way living microbes and lifeless chemical reactions produce methane, the microbes may contain clues about their origin as well. Early in Earth's history, life may have mimicked geological processes that occurred naturally, she said, and in the future the researchers hope to learn how much of this methane is out there and where it's being stored. This was from Joanna Klein from The Independent, and it's on Augmented Reality. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.